Welcome to this session on Pearson Correlation Analysis using Spss. So I will demonstrate how to perform a Pearson Correlation Analysis on Spss using an example. So suppose we have a research question, which is, does students' level of motivation to study influence their academic performance? So this is our research question. We therefore have two variables, which are level of motivation our first variable, and the second variable, I think, performance. And we just want to know whether there is a relationship and association between those two variables. Theoretically, we expect level of motivation to impact on academic performance, but we just want to see whether they are correlated with each other. And based on our theoretical argument, we can then say that it's level of motivation which influences academic performance. So if we have such a research question, which relates to only two variables like that, right? And suppose that both variables are numeric, or more specifically measured on an interval or ratio scale. So we are not dealing here with categorical variables, but rather numeric variables or variables measured on an interval or ratio scale. Let's write it like that. So numeric. So to test the relationship between those two variables, provided the assumptions of linearity is met, the assumption of linearity, and also the assumption of normality, provided those two assumptions are met, we shall test for the correlation, for the association between the two variables using the Pearson Correlation Analysis. So let us now perform the test while also verifying whether those assumptions are met. So let us proceed now and look at how we're going to do the test using the Spss software. So that's our data set. And we have here the variables of interest. Motivation is one, and performance is another one, academic performance. And suppose those are the two variables which are of interest to us. So those are the steps. We go on analyze, correlate, then bivariate. So those are the steps to perform a Pearson correlation analysis. Now, before doing that, we just want to verify whether the assumptions of linearity and the assumption of normality are actually being met. So first of all, to check for the assumption of linearity, we go on graphs, legacy dialogues, and scatter. So basically here we want to have a scatter plot which will allow us to visually inspect the relationship, the type of relationship that we have between those two variables. So we therefore click on scatter, simple scatter, define, we choose level of motivation and account performance. So you always want the independent variable to be included in the x-axis, and y-axis you'll have a dependent variable. And we click on OK, and we get our scatter plot. So here it is. So clearly here we have a linear relationship. If it was non-linear, you would have seen but we could actually fit a curve. Okay, it could be quadratic, cubic, or whatever, but you'll see a non-linear. Here it's clearly linear, whatever we can see here, right? So that's one thing. Second thing, you want to check the assumption of normality. Now, there are various ways to check that. I would suggest just to look at the kurtosis and skewness values and just see whether roughly they fall between minus 1.5 and plus 1.5. We have different recommendations regards to that, but minus 1.5 plus 1.5 seems to be reasonable. So what do we see here? For our cut performance, the first variable, skewness minus 0.094, kurtosis minus 0.634, skewness for motivation, the second variable, 0.032, and kurtosis minus 0.502, and obviously those are quite low values, which indicate that there should not be any issues when it comes to normality. So now that we're good with regards to our assumptions, we can proceed and perform the Pearson correlation analysis. So we click on Analyze, Correlate, Bivariate, Motivation first, then account performance second. Does it really matter actually for correlation, because we're looking at the standardized covariation between the two variables. So does it really matter? So we choose those two. Pearson should be selected. By default, it is selected. Just check that. We need to choose between a two-tail and one-tail test. All right. So in case we already have an idea about a clear idea whether the relationship will be positive or negative, we might choose a one-tail test. But it's advisable to go for a two-tail to be on the safe side, because if you have an unexpected result, it will not detect it. So we go for a two-tail test. And we click on OK, and here are the results. So we get a Pearson correlation of 0.822, and we get a significance value of 0.000. So those are the results here. So now let's make sense of those results. So we're going to interpret the results. So the first thing, of course, you report that the assumption of linearity has been met. So you report the scatter plot. And then looking at the kurtosis and skewness, between minus 1.5 and 1.5, we give actual statistic, skewness of kurtosis, we're fine. And then we look at the main results. So those are the main results. What is what we want to interpret here. So I'll just take a quick picture of that. Okay. And let's look at the interpretation. Let's put it like that. And let us interpret the results. All right. Sorry for that. And here we are. Here are the results. Okay. And we should be able to answer our to basically find an answer to our research question. Right. So I forgot to mention that this data set is based on a sample of 106 observations. And so that we're clear about the example, let us put it in a context. So let's say we're looking at so students, let us say um, university students, and let me put it into a more specific context. So let's say from Mauritius, University of Mauritius students, and that's a specific research question. So we have a sample of 106 observations. We know that the population of the University of Mauritius, students of the University of Mauritius, is around 10,000. And we have a sample of 106. Let's be clear about that. So what do we get as results? So here we see that we have a correlation coefficient here of 0.822. Now that's similar here. You don't need to interpret both. Those are going to be the same thing because whether you correlate motivation with ACAD performance or ACAD performance with motivation, you get the same thing. You're looking at standardized covariation. So then we have a significance value, and that's the second thing which we want to interpret, isn't it? Okay, so let's look at that. So first, so we look at the Pearson correlation coefficient, and what's the first value that you want to interpret? A Pearson correlation coefficient, 0.822. Now, how do we interpret that? The first thing which we want to pay attention to is a sign here. If you have no sign, actually, it means that it is positive. Otherwise, you would have obtained a negative sign. So the interpretation of a correlation coefficient is like that. Okay, the correlation coefficient denoted by the letter R. Okay, so normally R varies from 0 to +1 for a positive relationship, and from 0 to -1 for a negative relationship. So +1 will indicate a perfect positive correlation, whereas -1 will indicate a perfect negative correlation. All right. And anything in between. So normally you will never get -1 or 1. That would be too good to be true. That's almost impossible to get. You have something within the continuum, along the continuum. So we need to be able to make sense of it. So a very common guideline which is used is the one provided by Cohen in 1992. And Cohen basically tells us that anything along 0.1, so of course our modulus, because it's valid for either a negative relationship, correlation, or a positive correlation. So if it is around 0.1, we would say that it is a small effect. If it is around 0.3, we'll qualify it as a medium effect. Around 0.5 modulus, you qualify it as a large effect, right? And so we get 0.822. So therefore we can say two things about it. We can say that there is a strong, a large, strong, or even very strong positive correlation between the two variables, that is motivation level of students and their academic performance. Okay. Now, what's the first part of interpretation? Okay. Now, this statement is valid only for our sample, isn't it? At least as at now. Okay, so whatever we can conclude here based on the Pearson correlation coefficient pertains to our sample. So there is a strong positive. So we might say here, but it's just to be clear, among the sampled students, okay, we can find that there is a strong positive correlation. What's the first part? The second part of interpretation of a Pearson correlation analysis would be to look at the significance value, obviously. Okay, so that's first what you want to do, look at the Pearson correlation coefficient. Second thing, from the SPSS output, okay, so what's your SPSS output, isn't it? So the second part of the interpretation, you want to look at the significance value, what we also refer to as the p-value. Right, so significance or p-value. And it equal to 0.000. And for this, we just need to compare it with our significance levels. So normally we use 0.05. So if it is less than 0.05, basically you will reject your H note. Okay, so I'm not going through that in detail here. Okay, but obviously your H note here is that there is no correlation between those two variables, that is motivation level of students and I think performance. Basically, we conclude that the correlation is statistically significant. The strong positive correlation which we observe here is statistically significant. And so, and we've reached the end of this tutorial on Pearson correlation analysis using SPSS. Thank you.